Welcome to the class today. We are going to look at tunneling. So first of all, we would wish to know what a tunnel is. So a tunnel is an artificially constructed underground passage to bypass obstacles safely without disturbing the overburden. So to be able to do a tunnel, then you will be required to do excavation, which will give you a way through an obstacle to allow you to connect the 2 points. So tunnels are a cheaper way of bridging two positions or points that are separated by an obstacle as compared to bridges or open cuts, especially when you want to transport the public. The rock material and the geological conditions will play a major role in the stability of the tunnel that you wish to construct. So there are three formations that resemble the tunnel. So we have the open cut, which is an open to sky passage excavated through a huge soil mass or obstacle in the required direction to connect two roads or railways. So like for example, like on the picture that you can see there, that one is an open cut. So the difference between an open cut and a tunnel is that the open cut is open to the sky. Then a bridge is an overground construction to cross over obstacles without disturbing the natural way that is below the obstacle. Then for a tunnel now, it must be completely enclosed on all sides along the length. The ratio of length to width in a tunnel should always be at minimum 2 to 1 there. So that ratio is very important, of the length and the width. We have some relationships between underground structures. So the different parts that constitute a tunnel. Number one, we have the portal. So the portal is simply the entrance. On the diagram that is below there, you can see we have an east portal and a west portal. So we can have the east portal as the entrance and the west portal as the exit. We have the roof of the tunnel, which is also known as the crown. So this one is the overburden that remains when you do excavation. Then you have the bottom half, which is the invert. The basic geometry of a tunnel should always be a continuous arc. So the arch is able to take in the pressures and the forces that act on all sides of the tunnel. So it is the most ideal shape for that job. Then the arch goes all the way around the tunnel. So the upper part and the bottom part. We also have shafts. These are hand dug or dug with boring equipment. So they are vertical and they are short. So from the top of the overburden up to where the tunnel is. They are either as part of tunnel project to analyze the rock or the soil, or in tunnel construction to provide headings or locations from which tunnels can be excavated. So these shafts can also be used to supply pipes and cables for lighting of the tunnel and other effects that may be needed when the tunnel will be functional. So they begin from the surface of the overburden to where the tunnel runs through, like you can see in the picture below there. So you have the two shafts that begin from above, from the top, and they end at the tunnel there. You can see how they interact or they form the structure of the tunnel. Then we have the physics of tunneling. So engineers will be concerned mainly with the statics of the old tunneling construction. So the statics in this case will be a function of four important forces. So we have the tension forces, which expands or pulls on materials. We have the compression forces, which shorten or squeeze a material. Then we have the shearing forces, which cause parts of a material to slide past one another in opposite direction. And we have torsional forces, which twist a material. So if the engineer can be able to take care of this kind of forces, of the four forces, then they can be sure that the tunnel will be stable and able to perform the structural functions that is required